Let's start the class. Okay. So good afternoon, guys. Welcome to Chandu Biology classes. So this series is mainly for the IIT JAM people, that is physics, chemistry and biology, right? So in this class we are going to concentrate on the physics subject and the lesson is gravitation, right? So let us wait for 1 or 2 minutes. The people are joining over here. Yes. Okay. So let's start the class now. Okay. See, so in the previous class we were discussing about the work, energy and power. See, whatever the topics which we are discussing, no, like it will be important only, like important topics only we will discuss in the particular lessons for the IIT JAM people, right? So in this lesson we will discuss about in this session we are discussing about the topic gravitation. Right. So the first point what we are going to discuss is Newton's law of gravitation. So every body in universe attracts every other body with force which is directly proportional to the product of their masses of two bodies and inversely proportional to the square of the distance between them, which means like I am considering a object 1 and object 2. So object 1 mass is m1, object 2 mass is m2. So the force will be directly proportional to m1 and m2 and a force is inversely proportional to r square. R is nothing but the distance between the two masses. Suppose if I take the two objects with a long distance, the force between them will decrease, because if I talk about the distance and the force, it is inversely proportional. So I can say that if r decreases, force increases. If r increases, force decreases. So this is the relation between force and the distance between the objects. So this is my equation 1 and this is my equation 2. So since I have force and masses and force and distance now, so force is directly proportional to m1 and m2 by r square. To remove the proportionality we are adding a constant called g. So F is nothing but, like, the force of gravitation is nothing but g m1 m2 by r square, where r is the universal gravitational constant which is 6.67 into 10 power minus 11 Newton meter square per kg square. So this is the gravitational constant, like the SI unit, right? And I will say how we got that SI unit also. Wait a minute. Yes. Yeah. So if I talk about force is equals to G m1 m2 by r square. So G will be equals to F into r square divided by m1 m2. So we know that force is nothing but Newton and r is distance. No, distance we will calculate in terms of meter. So meter square per kg square. So this is how we got the SI unit of the gravitational constant. So the value is 6.67 into 10 power minus 11 Newton meter per kg square, right. So this is the Newton's law of gravitation, right. So the next topic is, yes, wait a minute, 1 minute guys. Yeah, now before that we will see a sum over here. Okay, so 3 equal masses of m kg are fixed at the vertex of equilateral triangle ABC. So what is the force acting on a mass 2m placed at the centroid of G of a triangle, and what is the force if the mass of the vertex A is doubled, which means if I consider this as m means now it has become 2m. So this is my first question, I need to find the centroid, and the second question, what will be the centroid force if A will be 2a, so 2m, that's it. Okay, can you find like how to approach this question? Okay, so let us solve now this question. Okay, so if I talk about these two objects, there will be a force for the centroid of 2m and the vertex A, and if I consider this two, they will be having separate force, and if I consider these two, they will be having separate forces. So if I consider every point, no, this every point will act on this 2m object, right. Now I need to calculate the force separately. First I will calculate, let me consider this point as G, okay, centroid. Yeah, they have given AG equals to BG is equals to CG is equals to 1 meter, like the distance between them is 1 meter, right. So the force of AG will be equals to G, m1 is m and m2 is 2m. Let me write the formula, like m1 m2 by r square will be equals to gm into 2m divided by 1 square will give us 2gm square, 2gm square. So is this in which axis? Y axis, and this is positive y axis, no. So let me write this as j cap, j cap. So if I talk about this B and G, C and G, they are making with some angle, right. No, they are made with some angle, and if I talk about that angle, this is 120 degree and this one will be 120 degree and this one will be again 120 degree. So if I want to take in x axis and y axis the components, no, I can separate like this. So this is my y axis, negative y axis, positive y axis, positive x axis, negative x axis. So negative x axis can be denoted as minus I cap, positive x axis plus I cap, and positive y axis plus j cap, and negative y axis minus j cap. Okay. So since A is in positive positive y axis, I have written j cap. Now I need to take the components for these two cases. So if this total is 120, and if I take a perpendicular thing, this one will be 90 and the remaining will be 30 degree, right. So 30 degree, no. So if I consider this one, this is my, yes, B cos 30 degree and this is my B sin 30 degree, right. Similarly, this one, this side it is C cos 30 degree, and this one in the downward again C sin 30 degree, right. So, now let me write the two things I need to get, like B cos 30 with G, B sin 30 with G, then B cos 30 with, C cos 30 with G, C sin 30 with G. Everything I need to write now. Okay, done. So, F BG will be equals to G, what is the mass? M and 2m. So, same thing, m into 2m by 1 square, 1 will be cos 30 degree plus another one will be G m into 2m by 1 square, and that one will be sin 30, no, sin 30 like cos 30 minus, that is minus I cap, and sin 30 minus j cap, sin 30 minus j cap. So, minus, no, so let me write over here. So, minus cos 30 degree and minus G m into 2m by 1 square sin 30 degree j cap. Okay. So, both are minus only. Now, when I talk about the C, no, like one will be positive and one will be negative. So, F CG will be equals to minus G m into 2m by 1 square sin 30 degree plus Gm into 2m by 1 square cos 30 degree, right. So, now I need to add everything, sum up every forces, like the force acting on G, right. So, total force will be equals to FAG plus FBG plus FCG, right. So, the force is here 2g m square j cap, 2g m square j cap, then and BG is nothing but minus 2g m square into I cap minus 2g m square j cap, right, plus 2g m square I cap, no, yes, minus 2g m square j cap. So, what is the thing I can cancel out here? This I cap and this I cap can be cancelled off, and this is sin 30, no, like I need to write here, that's cos 30 everything, no, sorry, this one I need to write 2g m square cos 30 degree I cap minus 2g m square sin 30 degree j cap minus 2g m square sin 30 degree j cap plus 2g m square cos 30 degree I cap, that is it, right. So, 2g m square cos 30 degree, 2g m square cos 30 degree will get cancelled off, right. So, the remaining will be 2g m square j cap, and this minus 2 will get get adds up. So, minus 4g m square sin 30 is 1 by 2 and this is j cap. So, this 2 and this 2 times will get cancelled off. So, 2g m square j cap minus 2g m square j cap. So, this is plus and this minus. So, again it get cancelled off. So, answer will be 0. Answer will be 0. So, I guess the camera is clear now. Okay, done. Okay, now the same question, when they have mentioned, when they mention this object will become 2m, and again this one will be m only, and this m will be m only. So this is A, B, G, sorry, C, no, C, and this is G. This is 2m. So one thing we can understand, when the objects are having a same mass, the centroid will be 0. The centroid, like the forces acting on the centroid, will be 0. When they are in the different masses, no, when they are in the different masses, the force will not be equals to 0. So now I need to calculate what is the force acting over here. Yeah. So now the forces acting by BG and CG I need to get, and AG will be nothing but force AG will be equals to G into 2m into 2m by 1, right. Here guys, so G into 2m into 2m by 1 square, that is J cap. Then FBG will be equals to, again the 30 degree will come, so I need to take the components. So minus G 2m into m divided by 1 square into I cap. I cap in the sense it's a cos 30 degree, right, cos 30 degree minus gm into 2m into m by 1 square, that is J cap sin 30 degree, sin 30 degree. Okay, so next one is FCG will be equals to minus G into 2m into m by 1 square I cap. So this one will be positive, I cap will be positive, cos 30 degree minus gm, so G into 2m into m by 1 square, J cap will be sin 30 degree, right. So the total force, so F total will be nothing but FAG plus FBG plus FCG, which is nothing but, and this J cap I'll keep as it is, so 4G m square J cap, and this one will be minus 2G m square will come, no, so minus 2G m square cos 30 degree, that is I cap, minus 2G m square sin 30 degree J cap, plus 2G m square cos 30 degree I cap minus 2G m square sin 30 degree J cap. So this is my forces when I add everything, and this minus 2G m square plus 2G m square will get cancelled off, minus 2 and minus 2 will get added up, so will be nothing but 4G m square J cap minus 4G m square sin 30 is 1 by 2, that is J cap again, so 1 times and this is 2 times, so 2G m square J cap is the F total. So this is the force acting on the centroid, this is the force acting on the centroid. Okay, so we'll go for the next topic. Yes, so gravitational field or gravitational field strength. So first of all, we'll learn what is gravitational field. So every object that has a mass attract other object towards its gravitational force, right? Suppose if I talk about any objects in the earth, like if I keep an object in a free space, it will try to go down due to the gravity, right? The space around an object where this force can be felt is called gravitational field. For example, if I consider a system, okay, if I take a point here, will I know there is a gravitational field? Will I know there is a gravitational field exist? No, right? Suppose if I keep a mass there, some point mass m, I can know whether the gravitational is exist or not in that system, right? So before that there was a point, there was nothing, like I don't know anything about that field or that strength. But if I keep some mass over there, I know whether the gravitational field exists or not in that system. So for that, what we are going to do is, in the system I have placed in mass to experience a gravitational field. So the gravitational field is denoted by the letter E, and the formula is F by the point mass m. So what is F here? F is nothing but G capital M small m by r square, where capital M is nothing but mass of the earth, and m is nothing but object, mass of the object. Okay, so the distance between the mass of the earth and the object is nothing but the r. Okay, so E divided by m. So this m and m will get cancelled off. So the value of E will be Gm by r square. This is the formula for the gravitational field, right? Yes, this is the system. Done. We'll go for the next one. Okay. So the next topic is acceleration due to gravity of Earth. Okay. So now we know the value of gravity, right? It is 9.8 meter per second square. Now we will see how we got that gravity value. So the force of gravity acting on a unit mass of a body lying on or near the Earth's surface. So we know the formula, F is equals to G mm by r square, where capital M is the mass of the Earth and small m is the mass of the object, right? And r is the radius of the Earth, right? Radius of the Earth. The point mass which I have kept on is nothing but on the surface of the Earth, right? So one more thing, we know that force equals to mass into acceleration. This acceleration we will rewrite as gravity, right? So this is equation 1 and this is equation 2, right? So from these two equations I can cancel this. Let me write here, Gm small m by r square will be equals to m into g, like small m into g, right? Small m into g. So m and m will get cancelled off. G will be equals to Gm by r square. So we know the value of gravitational constant G, we know the value of mass of the Earth m, and radius of the Earth is r. So it is 6.67 into 10 power minus 11 into 5.96, like approximately 5.96 into 10 power 24, like mass of the earth, and the radius of earth is 6.38 into 10 power 6. So whole square will get the value approximately 9.8 meter per second square. So this is how we got the gravity of the earth. Okay. Done. So can we go for the next one, next topic? Okay. So now acceleration due to gravity above the earth's surface. Above the earth's surface in the sense I am taking the object just above the earth's surface, which means above the height h. Okay. Now what happens? So this formula is there, no? F is equals to G capital M small m by R square. This R square I can rewrite as R plus h. So G capital M small m by R plus h the whole square, R plus h the whole square. So R plus h the whole square will be equals to m into GH. GH is nothing but gravity at the height h. So by doing the derivations now, we will get a relation GH will be equals to G times of 1 minus 2h by R, 1 minus 2h by R. So G will be decreases when height will be increases. G will decreases when the height will be increases. So the value of GH, like the gravity of object when I take to the height h, the formula is G into 1 minus 2h by R, where G is the gravity 9.8 and h is the height which I have taken and R is the radius of the earth. You can take a relation of this. Okay. So next one is acceleration due to gravity below the earth's surface. So let me give the direct formula for this. So gravity due to the depth will be equals to G into 1 minus d by R, where d is the depth and G is the 9.8 meter per second square and R is the radius of earth, right. So this is the formula for the gravity at depth d. So next one we will see the Kepler's law. So Kepler introduced 3 laws. Okay, the first law which we are going to see is all planets move around the sun in elliptical orbit with the sun situated at one focus of the ellipse, So in ellipse, no, like all sides will not be equal. There will be a bulge side and there will be a less bulge side also. Like it's not equal like a circle. When I talk about a circle, like the radius, I mean the distance from the center to the surface will be always equal, but here it will not be equal, right. So there is 2 things. One is major axis and one is minor axis. So minor axis will be a less distance and major axis will be a longer distance. Okay. So major axis is 2a and minor axis will be 2b. So semi-major in the sense, this is my semi-major, only half of the major. Semi-minor in the sense, only half of the minor axis. Okay. So this is first law. The second law is nothing but a line that joins any planet to the sun sweeps equal area in equal interval of time. Suppose if I talk about the sun is located here, the sun is located here. So initially at the planet was here, okay, at time t1, at time t2 the planet was here. When I talk about the area, it has been swept, no, it has been swept is, let me take this as 5 meter square for example, okay, and now the planet was here, okay, this is P, Q and this R and this is S, okay. Now the planet was here at time t1, at time t2 it was in S. So when I talk about this area also will be 5 meter square only, 5 meter square only. So it can be anything, okay, it can be anywhere, but if I talk about the time, no, like equal interval of time, equal area will be swept, okay. So this is Kepler's second law and the formula is, yeah, delta A by delta T will be equals to constant, which can be rewritten as delta A by delta T will be L by 2m. So L is nothing but angular momentum and m is nothing but mass, right. So A and T is nothing but area and time. So area and time will be equals to L by 2m. A by T will be equals to L by 2m is the formula for the Kepler's second law. And the third law is nothing but the square of time period of a revolution of planet is proportional to cube of semi-major axis. Cube of semi-major in the sense, semi-major I have taken as 2a, I mean major I have taken as 2a and semi-major will be a. So time period, the time square will be directly proportional to a cube, right. So this is Kepler's third law. Okay, so we will go for the next topic. Yeah. So here is the concept which are included like gravitational potential energy, force from potential energy near the earth surface for the multiple masses. Okay, so we have seen about the gravitational field, right. Now the gravitational potential formula is U is equals to minus Gm by R, yes, Gmm by R, and force is nothing but F is equals to minus du by dr, minus du by dr, which is nothing but minus Gmm by R square, okay. And when I talk about the near the earth surface, the potential energy is mgh, no, mgh. We have talked about this potential energy and kinetic energy in work power energy, no, work power and energy, right. So there we have talked about the potential energy in the earth surface, which is nothing but mgh, and the normal gravitational potential energy formula is U is equals to minus Gmm by R, okay. So the relation between the force and potential energy is F is equals to minus du by dr, or else I can say d minus du will be equals to F into R, that's it, okay. So this is the relation between force and potential energy. So if I talk about an object, triangle is there, okay. So let me take this A, B, C, having equal masses in the vertices, okay. Now I need to find what are the potential energy acting here, what are the potential energy acting over here, right. So if I talk, A will be acting on B, A will be acting on C also. then B will be acting on A also, B will be acting on C also. If I talk about C will be acting on A, C will be acting on B, right. So, the sum of potential will be, the sum of potential energy will be, see here I have given potential energy minus Gmm by R. For multiple masses it is the sum of Gmm by R, the sum of every potential energy, no, yes. UAB no will be equals to minus G m square by R. Next, so AB, BC, CA. Next, UBC will be equals to minus m square by R. UCA will be equals to minus GM square by R. So the sum will be like sum will be U total will be equals to UAB plus UBC plus UCA, right. So I can say that minus Gm square by R plus, okay, minus I'll write minus Gm square by R, again minus Gm square by R. So if I take minus Gm square by R, no, I'll get minus 3 Gm square by R. So this is the U total, right. So suppose if the object is given like a square, let me take, yes, object is given like a square. So mass m, and this also m, and this also m, A, B, C and D. Now how we need to write is UAB will be equals to, and this is distance A, let me take A, okay, square of side A having equal masses in the vertices, what is the potential energy of that system, So UAB will be equals to minus G m square by A minus G m square by A. Again now U will be acting on B, A will be acting on B, A will be acting on C, A will be acting on D also, right. So I'll write first in the vertices, okay. BC will be equals to minus Gm square by A, UCD will be equals to minus Gm square by A, UDA will be equals to minus Gm square by A. Then what else is left out? AB, AC, right, AD, right. Now BC, then okay, let me write AB, BC, CD, DA. A will be acting on C, B will be acting on D. Two things, that's it, no? AC and BD. Is there any other things? AB we have written, AC we have written, and AD also we have written. Now BC is there, yes. CD is there, yes. Then BD is there, yes. BD is also there. Where BD? Sorry, this is BD, no, not BC. BD, yes, it's there. So everything we have written. Now only things I need to write the formula for these two cases. So what is the distance between AC? If this is A and this is A, and this one will be root 2A, no? So root 2A, okay. So UAC will be equals to minus Gm square by root 2A. Again UBD will be equals to minus Gm square by root 2A. Now I need to add everything. So U total will be equals to UAB plus UBC plus UCD plus UDA plus UAC plus UBD. That's it. Everything written, everything we have completed. Now this is minus Gm square by A, minus Gm square by A, minus Gm square by A, again minus g m square by a, and this 2 will be minus g m square by root 2a minus g m square by root 2a. I can take minus g m square by a commonly outside, minus g m square by a commonly outside, 1 2 3 4. So, 4 plus this one will be 2 by root 2, 2 by root 2. So, I can rewrite this one as root 2 by root 2. So, this root 2 and this 2 will get cancelled off. So, minus g m square by a will be, say, a into plus 4 plus root 2. So, this is my u total. Excuse me. Okay. So, we have talked about up to potential energy, right? So, we will see some more topics in the upcoming session. Okay, we will meet in the next class, guys. Bye.